Hi folks. So I was talking the last time I spoke about my Mixologist project to automatically mix nutrients, about my problem of ensuring that these pumps are actually dispensing when I think they are and detecting conditions like leaks in hoses, broken pumps, run out of nutrients, empty tanks, that kind of thing. And got a few different ideas, but one of the things I wanted to try was doing it capacitively like the touchscreens on phones. So to that end, I ordered one of these little capacitive touch test boards. It's I can't remember what the chip is, it's got some little microchip on there and pretty much nothing else. Cost something like £1.12 delivered from China for me, so dirt cheap thing to have a play around with. So let's give it a try. So I've just hooked this up to a 5-volt power supply. The ribbon cable was just for convenience because I couldn't get crocodile clips on the pins itself, and nothing else. Just plug the thing in and straight away we've got the default mode that whichever sensor you touch or come close to lights up the corresponding LED. So this board has got a design problem. If you light up too many LEDs at once, I think it crashes the internal power supply on that chip and you have to reset it, but let's not worry about that for now. So what's going on with this thing, we've got a little tiny capacitor above each of the pads, and when you come close to this metal area here, it detects the changing capacitance and puts the light on. So that's what I want to use, but obviously I don't want to use my finger for changing the capacitance. I want to use some kind of liquid. So if I just clip this wire on, let's get it on the edge of that capacitor where the pad contacts. There we go. You can see that that now knows the capacitance has changed and gone up. When I take the power off and put it back on again, the unit measures the capacitance for the first time and finds out what it's got attached. So now this entire wire becomes my touch sensitive area. So you can see it's a hair trigger now. It can actually detect, I don't need to touch anything even, it can detect just the fact that my finger's getting close to it. Now of course my finger is 70% water, as is all of humans. We're all about 70% water, and that's the main element that's changing the capacitance here. So rather than just using my finger, I can use a pot of water for the same job, and there we go. It's found that and it's put the light on. Oh, I haven't actually. There we go. Oh, not quite as sensitive as I thought. There we go. Right, so with the water on, it's detected that something's touching it. Now, obviously that's a huge amount of water, and I want to detect much smaller quantities of than that. So the way I thought about doing that is, obviously the amount of wire I have dictates the capacitance of the thing. So I thought I'd have a little try and see what I can do with this syringe. I'm just going to wrap, I've just twisted the ends together at that end, I'm just going to wrap this wire around the hose here, and I'm hoping that when this tube is filled with liquid it makes enough of a difference, let's move that down to the end a bit, makes enough of a difference to the capacitance that we're able to pick it up. So we'll hook ourselves onto there, we'll give this thing a power reset so that it works out afresh what capacitance it's got, and there we are. It sees nothing attached at the moment, which is superb. So let's just try and get some water in here. Right, so if we get some air in the tube, we see that the light's gone off, and if I give this a squirt, I'll just put the pot at the other end. If I give this a squirt, it's a bit of a hair trigger here because there's metal work under the desk here, and when the wire gets too close to the metal it's making a big difference. But if it's not really working as well as I thought it would. Quite a hair trigger. There you go, so with water in the tube, no, we're not quite right. Let's try winding that again slightly differently. Right, so what I've done here, I've just clipped a crocodile clip onto one leg of that capacitor, which means this whole wire's become very sensitive now. That's a bit of a design problem, but we can solve that. And I've run a wire round and round this plastic tube. And obviously if I go near it, it detects, but it should also detect now water. So I'll stick some water in the syringe. Make sure that end's dry. There we go. So now there's no water in the tube. The light's gone off. And now when I squirt the water, you can see that we're detecting that liquid. And I'm rather pleased to note that it's not just liquid in the tube, it seems to make a difference if the liquid's flowing. As soon as I apply a bit of pressure to the syringe, that's amazing actually. Possibly too good to be true. And now we've run out of liquid, and no matter what I do here, it's not putting the light on. So it's not my actions it's detecting, it's definitely finding the liquid in the tube. Soak that up, and then give it a squirt, and a little squirt, just a drip. So that appears to be doing quite a reasonable job, surprisingly good job, of detecting liquid flow. I'm going to try integrating that with a pump. Right, I'm not sure which way, yeah, we are sensitive there. Not sure which way the water's going to run through this pump, but I'm just going to try and see what happens when I turn the pump on. Give it some power. Here we go. And we're pumping the wrong way, so we're just pumping air through, but this is good because this shows us that we're not triggering the light when we're just pumping air through. That's a good sign. I'll just swap these two hoses over. So this time we're going to have water coming out of this black hose in a second when I get it to sit still. Right, let's give it a try. And we're getting occasional little blinks on our red light. Now, interestingly, I wonder if that's actually related to the fact that our flow isn't continuous. Not quite reliable enough on detecting the flow there. See what happens if I let it breathe some air. Well, it certainly knows that the liquid's stopped flowing now. And if we go back to some water coming through, there we go. We seem to be getting a bunch of pulses coming through as the pump runs. So that's actually quite useful. So once again, I'll just pull that one out so we start sucking air in, and we know that we're sucking air, and back to water, and once it has the time to work up through the hose, there we go, we start to get a blink to indicate we're running water. Now if I just turn the power off, we stop blinking, and power on, we will still not blink. Yeah, there we go, we're getting a few. Now I think with just winding that coil a bit more carefully, this could potentially be a solution for me. What really surprises me is that this seems to detect the liquid flowing rather than just liquid in the tube, because as soon as I turn the pump off, obviously we've still got liquid there in the tube. And it seems to require the liquid to be flowing to trigger that. That's really good. Really happy. I'm going to try winding that a bit more tightly and see what happens. So with the coil more tightly wound, we seem to have more of a liquid present detector than an actual flow detector. If I turn the power on, we can see that we do actually flash our light a bit as it detects bits where the water's coming and bits where it isn't. And if I lift our input tube out of the liquid, we get to the point where there's no liquid flowing and the light goes off, so we know there's no liquid in the tube. But once some more comes through, and we're back to flashing again. But if I just stop the pump now, well, that's a bit borderline. There we are. If I stop the pump there, the light's on, there's liquid in that section of the tube. Now, I've had a thought about this, that of course the tube's really not serving much purpose here. What we're doing is we're detecting the water falling down the middle, and that's what's making the capacitance. So I wonder if I could rig something around the outside of one of the tubes such that it's not measuring the tube, it's measuring the water as it falls out the end of the tube. Let's have a go. So I've spent a while trying to make smaller and smaller coils with the idea that I can detect the liquid as it drops through the middle. But I've hit the problem that because the flow of liquid's very small, if the coil's too big then it can't detect the liquid, and if the coil's too small then it gets drips on the inside and the liquid stays on the inside, and then this little board doesn't reset itself properly. Well, I've now simplified my sensor down to just a piece of aluminium tape wrapped around this bit which is the inside of a biro, and that seems to work quite well. Let me just zoom out so you can see the board. Yeah, so now when I run the pump it's just got air in at the moment, so we're not detecting anything, and once that starts getting water flow, there we are, we see we've got water flow. So that's quite good, but the problem with this setup is that when this powers on, that's when it measures the capacitance. So now we've powered on, we don't know that we've got water in the tube anymore, and when we start flowing we're not detecting it. And I need air flowing through that when I actually power on this capacitance board. Power it on now, and now that it knows the capacitance with air, when the water flows we can detect it, which is quite useful. I wonder if I can use the same trick with something else. I have a cunning plan. Right, I've had a look at the datasheet for this thing, and it says that the sensitivity is actually adjustable by changing the values of these 4 capacitors here. The most sensitive is with no capacitor at all fitted, so I'm just going to pop those capacitors off, well, pop that capacitor off. It also says to keep the traces as short as possible, which makes a lot of sense, so I'm going to connect it up without the crocodile clips and solder a wire on there instead, and we'll give that a try. So with a bit of fine tuning to the shape of this piece of foil here, which is obviously very sensitive to anything metallic going near, in fact anything liquid going near it, we do actually have quite a reasonable run indicator there for our pump, and it seems to survive power off and power on conditions okay, I say, as it fails to do that. But there we go, I'm back to working again. So I think that can be made to work. A bit more fine tuning required, but certainly seems to be fulfilling the job of telling me when the pump is running with a regular pulse every second or so. Gives me confidence that things are working. So just reducing the component count one more, I've done away with the piece of foil because just having this individual wire doesn't catch so many drips, which means it basically becomes fairly reliable now. When the water's flowing, the light's flashing, and as soon as I stop, it stops. And if I power cycle the touch controller board, which I'll just do there now, back on again, there we go. So we're now blinking away again happily. But I think all I really require here is a little mechanical finesse to prevent the drips from staying on. Let's try a power off, power on. There we go, working away again now. I mean, this is quite encouraging, but I think this may require more fine-tuning than is worthwhile. I'm going to carry on looking at other options, but this is certainly the cheapest way I've found of doing it so far. and one of the easiest, since this gives me direct digital output to indicate I've got a flow running. Anyway, hope you enjoyed that, folks. Perhaps someone will find this useful. Thanks for watching, and see you next time.